Hello everyone, my name is Arya Devdar and this is part 2 of NCERT Class 10 Science, Chapter 2, Acids, Bases and Salts. Okay, so in part 1, we covered the brief introduction of acids and bases, and we also went into deep about indicators, right? Different types of indicators, so natural, synthetic, and olfactory. Okay, so in this part, we are going to start with the reactions, okay, which is very important. Okay, so in this part, we are going to see the reaction of obviously acids as well as bases with, so firstly, reaction with metals. Okay, reaction with metals. Secondly, we have reaction with metal carbonates, with metal carbonates and metal hydrogen carbonates or metal bicarbonates. And I read bicarbonates, but another name for it is also hydrogen carbonates. Okay, I'll explain what that is, right? And the last one is we are going to see the acid-base reaction, or also known as neutralization. Correct? Acid-base reaction. So these three reactions we are going to see in this part. So let's start. The first one is reaction with metals. Okay. So firstly, we'll see the reaction of acids with metals. Correct? So acids. Okay. So you know that the examples of acids are HCl, H2SO4, HNO3, H3PO4, etc. Correct? So these are all examples of acids. Okay, now I'll write the general equation what happens when acids react with metals. See, acid plus metal, it gives a salt plus hydrogen gas. Hydrogen gas. Right, so this is the general equation or general reaction which occurs. So we'll understand this through an example. Okay, so what will the example will take will be Zn. Okay, acid first. So acid will take H2SO4. Fine. So H2SO4 is an acid. The metal will take Zn, zinc. Correct. So what will be formed? See, the salt which will be formed will be ZnSO4 and hydrogen gas will be evolved. Okay, so I read down the names here. This is sulfuric acid or hydrogen sulfate. This is zinc, right? Solid. ZnSO4 is zinc sulfate. This is the salt, right? And H2 is H hydrogen gas. So we have learned the meaning of this symbol in chemical reactions and equations. This means that a gas is being evolved, right? The symbol means gas is being evolved, and the downwards arrow it means a precipitate. Correct? So yeah, here hydrogen gas has been evolved. Okay, so let's understand the mechanism of this reaction, right? It's important because if you understand the mechanism of one reaction, you will be able to write any reaction if you are given the reactants or even if you're given only the products. Correct? So let's see this mechanism. See what happens. From H2SO4, you can see this is H2SO4, right? This gets removed. Okay. This part gets removed and it forms ZnSO4. So excluding H2, the rest of the part it is removed. It is called an ion, right? It is called an ion. Okay. So negative ion is anion and positive ion is cation, right? So we'll see more of that in metals, but for now just understand this, right? Besides H2, the other part is removed, and with Zn it forms a salt. So ZnSO4 is a salt, and the H2 gas it becomes independent to say, and it gets evolved, right? So this is the basic mechanism of this reaction. Okay. So let's see if it is balanced. H2, H2, Zn, SO4. Right. It is self-balanced reaction. Correct? Okay. But now you might ask that H2 is a colorless and odorless gas. Correct? So then how will we detect that H2 gas has been released? Right. When the scientists they did this reaction, how did they know that H2 gas has been released? It could have been carbon dioxide, right? Carbon dioxide or oxygen for that matter. Both of those gases are also colorless and odorless. So how do they know it is hydrogen? So there is a simple test for that. Okay, so we'll see that test here. Right, test for hydrogen. A test to check that hydrogen gas has been evolved. Right. So what you have to do, it's a simple technique. Basically, in the test tube in which this reaction is happening, okay, in the test tube where the reaction is happening, you have to bring a burning matchstick close to it, a lit matchstick close to it, right? And if you bring it close, the hydrogen gas, when it comes in contact with the burning matchstick, right, it produces a popping sound. It produces a popping sound, right? And this popping sound is a very characteristic sound produced by H2 gas. It is not produced by CO2 or O2 or for that matter any other gas. Only H2 gas can produce this type of uh, popping sound, right? So that is the characteristic test for H2 gas. So I'll just write that down in short. So basically, uh, bring a burning matchstick, right? Bring a burning matchstick near to the test tube, near to test tube. If it burns with a popping sound, with a popping sound, then we can conclude that then hydrogen gas has been evolved. So this is a basic test, correct? So in this way we can find out that hydrogen gas, or we can, justify that hydrogen gas has been evolved, correct? So this is the test with acids. Now you can do this with any other acid and metal as well. So for example, I'll keep the same metal, but I'll change the acid, right? For example, we have this is first. Second, if I take HCl, HCl plus Zn, right? So can you think and tell me what will be formed? I'll give you a hint. I'll give you a hint. Okay. See. Okay. So basically here ZnCl2 will be formed. ZnCl2 will be formed plus H2 gas will be evolved. ZnCl2 is zinc chloride. This is also a salt. This is the same hydrogen gas which has been evolved, correct? This is HCl. HCl is hydrochloric acid. Hydrochloric acid, and zinc is Zn. Correct? So this is another example of the same acid metal reaction. Okay. Now we'll see base and metal. How do base and metals react? Correct? Like what is the exact procedure? So you'll be glad that I will tell you that it's very much the same as acids. Okay, so yeah. Okay, so base for bases. Right? I'll write the general reaction is exactly the same, except in place of acid will write base, that's all. So base plus metal, it gives salt plus hydrogen gas. See, no difference. Okay, but the thing is here, for acids, most of the acids they react with the metals to produce salt and hydrogen gas. But bases, they all the bases do not react as easily with metals to form salts. Okay, not all the bases. So there is a specific reason for that, which you will learn in your higher classes, right? Not now. But just understand that for acids, most of the acids they react, but bases, not all the bases. Some of the very, very reactive bases, they only react with metals to form salt. Okay, so let's see an example here. So, example, base NaOH, sodium hydroxide, plus metal Zn. Okay, so what this forms, see, Na2ZnO2, Na2ZnO2 plus H2 gas. Okay, so NaOH is basically sodium hydroxide. Right, NaOH is basically sodium hydroxide, correct? Zn is zinc, and this salt which has been formed, it is known as sodium zincate. Okay, so it has a very peculiar name, and hydrogen gas has been evolved. Okay, so the reaction is sodium hydroxide plus zinc. It gives sodium zincate plus hydrogen gas. Okay, so this is the way in which bases, some of the bases, they react with metals to give salts and hydrogen gas. Okay, again for hydrogen gas, the test is the same one, the popping sound test. No difference, right? Okay, moving on. Now we'll see the second reaction, which is reaction with metal carbonates and metal hydrogen carbonates. Okay, these hydrogen carbonates, they are also known as bicarbonates. Okay, so you might see bicarbonate, you might see hydrogen carbonate, depends on the examiner, correct? So hydrogen carbonates and bicarbonate, same thing. So what exactly happens, right? So first we'll see acids, correct? So for acids, yeah, so see for acids what happens, right? So acid plus metal carbonate or slash hydrogen, or I'll write bicarbonate for short, right? So metal carbonate or bicarbonate. So this gives salt plus carbon dioxide, sorry, carbon dioxide gas plus water, right? So this is the basic reaction with acids. Okay, so we'll see through an example, correct? So two examples. With the same acid, we'll take a metal carbonate and a metal hydrogen carbonate, and we'll see what happens. Okay, so firstly, let's take a metal carbonate. So acid will take HCl, okay, and the metal carbonate Na2CO3. Okay, so this is the metal carbonate. Okay, CO3. There is no H involved. There is no hydrogen in it, so that is a metal carbonate. So HCl plus Na2CO3. This gives a salt. The salt is our common table salt, which is NaCl plus CO2 plus H2O. So CO2 is evolved. So we'll write that like this. Correct? So I'll write the names: hydrochloric acid. Na2CO3 is called sodium carbonate. Right? Metal carbonate. The metal here is sodium, so sodium carbonate. NaCl is sodium chloride or our table salt. Right? CO2 carbon dioxide, and H2O I'll not write. It is water. You all know. Right? Again, CO2 has been evolved, so hence the upper arrow. Correct? So the mechanism for this, see what happens here. This part, it gets separated out, leaving the H and leaving the CO3, right? Because H goes on to form H2O and CO3 goes on to form CO2, correct? And these two, they react to form a salt. Okay, so this is the basic mechanism which you can understand. The like exact mechanism you'll understand in the higher classes. Okay, so this reaction is not balanced, so let's balance it. So 2, right? And then 2Cl, so 2 here. Is it balanced? Yes, I think so. Okay, yeah, it's balanced. Okay, so this is what happens when acid reacts with metal carbonate. Right, now we'll check for metal hydrogen carbonate. Okay, so same acid we'll take. So here we have HCl, correct? Plus, now here we'll take metal hydrogen carbonate, NaHCO3, gives NaCl plus CO2 plus H2O. Right? So here there is no change. Right? I mean, the products are the same, but the reagents have changed. So the left side has changed. Correct? So here I'll write the names: hydrochloric acid, NaHCO3 is sodium hydrogen carbonate or sodium bicarbonate, whichever. Sodium bicarbonate, NaCl sodium chloride, and CO2 you already know, carbon dioxide, and H2 is water, right? So here, balancing, I think it's already done for us, right? Yeah, so it's a self-balanced reaction. So you can see the like wondrous thing that here, even though the reagents have changed, the products remain the same. The only difference in the products, if you notice, is this, that NaCl in the first reaction it has formed two times, like two times the amount it has formed in the second reaction, correct? So more NaCl has been formed in the first reaction. That is the only difference. There is no other difference, correct? So that's what happens when a metal reacts with metal carbonate. I'm sorry, acid reacts with metal carbonate or metal hydrogen carbonate. Now we'll see for bases, correct? So for bases, you have to understand that no reaction occurs when it is treated with a metal carbonate or a metal hydrogen carbonate. So here I'll write no reaction. So they will not ask you in the exam as well, like a base plus metal carbonate, because it's like it doesn't happen, right? No reaction takes place. But it's just for an info that you must know what happens. Correct? Again, the question arises here that for CO2, like how will we identify that CO2 has evolved, right? So again, it is a odorless and colorless gas. So again, there is a test for CO2. Okay, so we'll see that test for CO2. And remember that both these tests for CO2 as well and H2 as well, they're very important because a direct question is asked in the boards for 1 or 2 marks. Like the reaction is given, they ask some question regarding the reaction, and then they give the test for identifying carbon dioxide gas or hydrogen gas, right? So it's very important, you must remember it. Okay, so what happens for CO2? There a burning matchstick was brought near and a popping sound was heard, right? For hydrogen gas. For CO2, what happens? This CO2, it is treated with, yeah, so it is reacted with CO2 plus CaOH twice. This CaOH twice, it is calcium hydroxide. Okay, we have seen a reaction for this in our first chapter, chemical reactions and equations. And I told you at that time that it is a very important reaction, right? So if you remember, CaO plus H2O gives CaOH twice, right? So plus heat. So CO is quicklime and CaOH twice is slaked lime, right? Calcium hydroxide. Okay, so here the same calcium hydroxide it is used and it is reacted with CO2, or CO2 is passed through calcium hydroxide and it gives CaCO3. Okay, CaCO3 plus H2. Now this CaCO3 it is known as calcium carbonate. Calcium carbonate, or it is also commonly known as limestone, right? Chalk, marble, etc. So all these things they are basically calcium carbonate itself. Okay, and you know that it is white in color, right? So here, when CO2 it is passed through COH twice, a white precipitate is obtained. Correct? White PPT is obtained. Understood? So in this way, we can understand that CO2 has been produced. Correct? But now there is a condition that if you pass CO2 through COH twice for a short time, then CaCO3 is formed. Correct. But if you pass CO2, sorry, CO2 plus CaOH twice for a long time, right? So if it is passed for a long time, I'm sorry, this is not CaOH twice. Right. So if it is passed for a long time, then the CO2 it starts to react with CaCO3 formed. Okay. So what happens here? So CO3 plus CO2 plus H2O, right? So what this forms? This forms CaHCO3, right? This forms CaHCO3, which is known as calcium calcium hydrogen carbonate, CHCO3, or calcium bicarbonate, whichever one, right? So now this CaHCO3, this is soluble in water. Okay, so this compound, it is soluble in water, correct? So that means that the solution, it turns colorless. Okay, the solution, it turns colorless. So basically what happens here, firstly when you pass CO2 through COH twice, you will get a white color solution, from colorless to white, and then again from white it will go to colorless, right? So CO2 to CaCO3, CaCO3 to CaHCO3. So this is the process which occurs in steps, right? So you have to pass it for a short time to get the appropriate result, to get a white precipitate, to understand that CO2 has been produced. Okay, so hope you understood this metal carbonate and metal hydrogen carbonate reaction. Correct? Now we'll move on to the last reaction, which is the acid-base reaction. So you might have understood from the name, acid-base reaction basically means the reaction of an acid with a base. Okay, and this reaction, it is also known as a neutralization reaction. A neutralization reaction. So the general formula for it is acid plus base produces salt plus water, H2O. So this is the general reaction, right? So basically the definition of a neutralization reaction is when an acid reacts with a base to produce a salt and water, it is known as a neutralization reaction. So the actual meaning of neutralization, it means that acid has neutralized the effects of the base and the base has neutralized the effects of the acid. Hence it is known as a neutralization reaction. Okay, so anyways, we'll see an example here. So acid, let us take HCl, correct, plus base NaOH, both are very common, right? It will produce the salt NaCl and H2O. Okay, here again the mechanism, you can see NaCl and Na, and this H will combine with OH to give H2O. Okay, very simple mechanism for this, right? So HCl is hydrochloric acid, NaOH is sodium hydroxide, NaCl is sodium chloride, table salt, right? Sodium chloride, and H2O is water, correct? It is again a self-balanced reaction. Okay, so this is like the most common layman example for acid-base or neutralization reaction. Other than that, you can also, play with different acids and bases to form different salts, right? For example, just take an example. I'll take the salt, I'll take the acid H2SO4, correct? And the base, I'll keep it same, NaOH. So this will form, you can see here, right? It will form Na2CO4, Na2SO4 plus H2O. Na2SO4 is sodium sulfate, correct? Let's do one more. Let me take HCl plus MgOH twice. MgOH twice is magnesium hydroxide. It is also a base. So this will form here, as you can see, MgCl2 plus H2O. MgCl2 is magnesium chloride. It is again a salt. Okay, so like this, you can experiment with different acids and bases to give different salts. If you understand the mechanism of it, then you can combine any or react any two acids and bases to give your salt. So that's it for this video. So in this video, we have seen three very, very important reactions. First with metals, then when metal carbonates and metal bicarbonates, and then the acid base reaction, right? So that's it for now. Thank you so much.